you're a developer who's been dipping your toes into AI, you've probably had that moment. That moment where you realize the code, well, it doesn't really act like code. Today, we're going to break down the one massive mental shift you need to make to go from building frustrating AI projects to ones that actually work.
So let's just get right to it. The answer to this one question. It is the absolute key that unlocks everything else about building with AI. It's the line in the sand between the old way of thinking about software and the new.
All right, to really get what's so different, we have to start with what we all know. The world we're used to, the world of traditional software, is built on a foundation of absolute certainty. It's predictable.
And this right here, this is the great divide. On the left, you've got traditional software. It's deterministic. You put something in, you get the exact same thing out, every single time. But on the right, you have AI models. They're probabilistic. Same input can give you a different, but still totally valid output. It's really the difference between a calculator and a creative partner.
So let's just hammer this point home. Determinism means reliability. When you click that save button, you expect the file to save. 2 plus 2 is always 4, right? This is the bedrock, the very foundation of pretty much all the software we've been building for the last half-century.
Okay, so now let's jump into the new world. With AI, we're stepping off that paved road of certainty and into this kind of wild landscape of probabilities. And believe me, the rules here are completely different. For us developers, here's maybe the best way to start framing this. Just think of an AI model as another API endpoint. You use the Stripe API for payments, you use the Twilio API to send texts, and you use an AI model's API for intelligence. Simple enough, but there is one huge difference.
And that's it. That is the single most important part of this new mental model. Unlike basically any other API you have ever used, you can call it with the exact same payload, the exact same input twice, and get two different things back. You really have to let go of that guarantee of consistency.
So, you're probably asking, okay, if it's not following a strict script, then how in the world does it decide what to say? What is actually happening inside that black box?
Well, you can think of it as a ridiculously sophisticated prediction engine. It takes a look at the prompt you give it, and based on all the patterns it learned from, basically the entire internet during its training, it just calculates the most probable next word. Then it adds that word to the sequence and does the whole thing over again, word by word. You know what? Enough theory. Let's actually see this in action. We're going to ask a model a classic, very deep question, but we're going to force it to give us just a one-word answer.
Okay, first time we run it, we get purpose. Yeah, that makes a ton of sense, right? It's a really common, very probable answer when you think about all the philosophy and books it's read.
Now for the cool part. We're not changing a single thing, not one character. We're sending the exact same prompt to the exact same model. Now, in our old deterministic world, we'd expect to see purpose again. But this time, we get love, a completely different word, but also a really good, highly probable answer. And this is it. This is that probabilistic nature in the flesh. The model isn't just looking up a fact in a table. It's navigating this huge space of possibilities and picking a likely path every single time.
And this brings up another crucial point. We asked for one word, but you are not guaranteed to get one word. Sometimes it might give you a whole sentence. And this is so important. That's not a bug. It's a fundamental feature. The unpredictability applies to the structure of the response just as much as its content.
So now that we kind of get how these things think, how do you choose the right one? Because just like the tools in your toolbox, they're definitely not all the same.
It almost always comes down to a trade-off. You've got some models that are really fast and cheap, and they're perfect for simple stuff like, say, categorizing an email. Then you've got the heavy hitters. They're slower, they're more expensive, but man, they can do some serious heavy lifting, complex reasoning, writing code, you name it. The real skill is matching the right model to the right job.
And just to keep things interesting, this entire landscape is moving at lightning speed. The best model today might be second best in a few months. This means building your systems to be adaptable so you can easily swap models in and out isn't just a nice to have anymore. It's an absolute must.
Our conversations with AI aren't just about typing in a box anymore. We can now communicate using all sorts of different inputs and outputs, and these are called modalities.
And for a developer, this is an absolute game changer. I mean, think about it. You can start by planning a feature with text, then you can literally feed the model a screenshot of your UI and ask for feedback. And then you can just speak your complex instructions using your voice instead of typing it all out. It makes for a way richer, way more efficient way to build.
Okay, we've got the theory down. So what does this probabilistic world actually mean for us, the people who have to architect and ship production software? How do we build something reliable on a foundation that is, by its nature, a little unreliable?
All right, let's pull all this together into some practical rules for the road. First, and this is the big one, never ever assume the AI will give you the output format you want. This means you have to architect your systems to handle that variability. For any senior engineer out there, this means you need a validation layer, something that catches the AI's response, parses it, maybe using a library like Pydantic, and makes sure it's sane before it messes up the rest of your system. You need fallbacks, you need retries. Think of it like you're building a suspension bridge, not a rigid one. It has to be able to flex. Next, pick the right tool for the job. Don't use your most powerful, expensive model for a simple task. That's just wasteful. We also saw that you should embrace new modalities to build way cooler stuff. And finally, remember that this whole space is a moving target. Build your system so the AI model is a swappable part, not baked into the foundation. The goal isn't to fight the uncertainty, it's to build a resilient system that expects it.
And that leaves us with one last kind of provocative thought. Right now, most of us spend our time trying to box in the AI's unpredictability. But what if we didn't? As these models get smarter and faster, the really interesting question is, how can we start to redesign our apps to use that creative randomness as a core feature, instead of just seeing it as a bug we have to manage?